Okay, in this problem, we are going to be calculating the sample size that we would need to do in order to do a work study. All right, so in doing a work study, and this is laid out for you in your book on page 424. So basically, what you're doing here is a time study. You're trying to find out the sample size that you would need in order to do a study of a particular job. A time study is how many instances of a particular job you would need to look at in order to um, study it thoroughly, and how many repetitions you would need in order to collect enough data on a position. So this tells you um, how, the exact steps you would need to take in order to conduct a time series study. And it gives you the example of making a pizza, for example. And so what you're trying to do is find out in that example how long it takes for each step of making a pizza. So what you're wanting to do in your time study is find out, first of all, step one is to find out how many samples you need to actually look at in order to get an actual average of each step in the process of making the pizza. So this is step one, and this is what we're going to be doing in problem number 2. Okay, so we're going to be using this formula, and this formula does look kind of ugly, but it's actually pretty simple. The first two inputs that you need to have are given to you. It tells you in the problem that you want to be 99% confident in your results. So you're basically going to be looking these up. So if you want to be 99% confident, then you are going to be within 0.01% accurate. And you are going to be, um, let's see, I think that's what it, let me make sure before I tell you that. Sign back into our book here. Okay, let's go to our problem. Okay, so problem number 2 says, using the information in problem number 1, determine the sample size needed if the standard time estimate is to be within 5% of the true mean and 99% of the time. Okay, so 5%. All right, so let's go back, and it is 5% accuracy. So 0.05 is our accuracy, and 99% is going to be the number that we look up for our Z factor. And when we look that up in the charts on page 425 in your book, you will see that that number is 2.58. And this was 425 in the new edition of the book. Okay, so we're going to ready to put in our formula here, and we're going to be using a lot of parentheses. So you do have to kind of follow how many parentheses you use, so that becomes a little tricky. I'm going to start out using two sets here, the outside set and the inside set. So they do color code, Excel does color code them, so that makes it kind of nice. So just kind of keep up with your colors as you start typing them in. Okay, so it's our Z divided by RE, okay, close parentheses. And then we're going to multiply that by open parentheses. And then it is our standard deviation divided by our mean time, close parentheses, close parentheses. And then we're going to do a caret and a 2 and enter. Now, what I want you to do, if you are inclined to, is there's a couple of Excel tricks that we can do in order to create the correct answer as we copy these down. The first one, of course, is to use our absolute referencing. And we would need to use the absolute referencing anywhere there is an odd number. So these, of course, are going to be fine once they're copied down because there's numbers underneath them. But these two, they're not going to be okay because there's no numbers underneath them. So when we copy down, they're not going to move in the right direction. So wherever there's a B3 and a B4, we want to do our F4. So we're going to do an F4 here and an F4 here. Now, the second thing that I want us to do is come between the equal sign and the first parentheses right here. And I want us to use the round up function and put another parentheses around the outside. And then come to the end down here and put a comma and put a 0 at the end and put an end parentheses. Okay, and then just check on your check mark there. And then we're ready to copy that down. Okay, so what that's going to do is it's going to round up regardless of what you've got going on. It's going to round that number up. So before, this number had some trailing decimal places on it, and it was such that it rounded it down. So it wasn't it was under 0.5, so it had rounded the number down to 88. But what we want is to round up, because you can't have part of a person, so, or part of an item, or part of a time frame. So you always want to round up, because as soon as you go over a number, then you have to go to the next time frame. So in theory, you have to always round your sample size up. And then what you're going to do here is you're going to take the highest element in here. So our sample size would therefore be this one here, because it is the highest. So if you do a sample size of 89, then it's going to effectively incorporate all of the other ones. So you will cover all of the other work elements if you were to choose a sample size of 89. Okay, so that's the answer to problem 2. And you're going to do the same thing in problem 4. It's the same type of problem. Okay, and that's it for those.